Hello, Elevate Nation. Today, you will be able to explain equivalence of fractions in special cases and compare fractions by reasoning about their size. A fraction is a number that has equal parts of a whole. There are two main parts of a fraction. The first part of a fraction is the denominator. It is located below the fraction bar, and the denominator is the number of equal parts in a whole. The second part of a fraction is the numerator. It is located above the fraction bar, and the numerator is the number of parts being described. Fractions can be represented in many ways. We can use models to represent fractions. Look at the models below. Which model represents the fraction 1/2? If you selected the first model, you are correct. Great job. The first model is correct because the rectangle is divided into two equal parts. And the one part described is shaded. We can also represent fractions on a number line. The number line is divided into two equal parts from 0 to 1. The part before the point represents the parts being described. Let's identify the fractions based on the model. Let's look at our first model. The fraction for the first model is 1/2. The reason why the answer is 1/2 is because there are two equal parts and one part is shaded. Let's look at our next model. Our next model has 4 equal parts and 2 of those parts are shaded. Let's look at the third model. What fraction do you think represents the third model? If you stated that 4/8 is the correct fraction, then you are correct. The reason why 4/8 is the correct answer is because there are 8 equal parts in the whole. 4 of the parts are shaded. Even though the model is divided into different parts and the fractions have different numerators and denominators, we notice that all three have something in common. What do you notice that they have in common? Great observation. We notice that they have the same amount shaded. When the models of the fractions have the same amount shaded, they are considered to have the same value. If the fractions have the same value, we call the fractions equivalent fractions. Instead of drawing models, each time we want to identify equivalent fractions, we can use multiplication. Let's look at the fraction 1/2. If I multiply 1/2 times 1/1, I will notice that my answer will be the same. If I multiply the same factor by the numerator and the denominator, it will equal an equivalent fraction. Let's change the factors. Instead of 1/2 times 1/1, we can say 1/2 times 2/2. We can do this because the factors in the numerator and denominator are the same. If we multiply, we need to start with our numerators first, multiplying 1 times 2, and then we will multiply the denominators of 2 times 2. 1 times 2 is 2, 2 times 2 is 4, which equals 2/4. Let's try our next problem. This time, instead of 1/2 times 2/2, it will be 1/2 times 3/3. We will start by multiplying our numerators first, 1 times 3, and then we will multiply our denominators of 2 times 3. 1 times 3 is 3, 2 times 3 is 6, which equals 3/6. Let's look at our next problem. We have 1/2 times 4/. What number will replace our missing factor? The correct answer is 4. My new problem, or my new equation, is 1/2 times 4/4. We will continue the same process of multiplying the numerators first. 1 times 4 equals 4. And our denominators of 2 times 4 equals 8. And our final answer is 4/8. We notice that I can either draw a model to find equivalent fractions, or I can use multiplication to find equivalent fractions. Let's look at our next problem. Amber and Leslie buy 2 cakes. Amber's cake is cut into 3 slices, while Leslie's cake is cut into 6 slices. Amber eats 2 slices of her cake. If Leslie ate the same amount, what fraction of cake did she eat? After we have read our problem, we need to circle our keywords and numbers. Our first keyword and number are 3 slices. The 3 slices is referring to Amber's cake. Next, we have 6 slices, and the 6 slices is referring to Leslie's cake. Our next set of keywords is 2 slices. That's also referring to how many slices Amber ate. After we have circled our keywords and key numbers, we need to understand the question. The question is asking us to find a fraction that is equivalent to the amount that Amber ate. First, we need to figure out how much of the cake did Amber eat. Let's create a model to help us represent how much of the cake Amber ate. Out of the whole, she created 3 equal parts. Our model will be a circle with 3 equal parts. The problem also stated that Amber ate 2 slices of her cake. We will shade in 2 slices. Since we have 2 slices that have been described, out of the 3 equal parts, the fraction that can represent the model is 2/3. To see which one is equivalent, we will draw a model based on the answer choices provided. Let's look at our first answer choice. To represent 2 6, we must have 6 equal parts. Also, to represent the numerator and the denominator in 2 6, we must shade 2 of the parts out of 6. We notice from our models that the numerators are the same, but our denominators are different. We also notice that the shaded area is not the same amount. Because the shaded area is not the same amount, we can eliminate 2/6. Let's look at our next answer choice. 1/3. To create 1/3, we must create a circle with 3 equal parts. We must shade 1 of the parts. When we compare the 2 models, we notice the shaded area is not the same. It does not cover the same amount. Since the shaded area does not cover the same amount, we can eliminate 1/3. Let's look at our next answer choice, 4/6. To create the model for 4/6, we must create a circle with 6 equal parts. To represent the numerator, we must shade 4 of the parts. We notice that even though the numerators and denominators are different, the amount that is shaded is the same. Since they have the same amount shaded, we can select 4/6 as the correct answer. Let's see why 3/1 would not be correct. In the fraction 3/1, we notice the denominator is telling us how many equal parts. We have one equal part, and that equal part is displayed or described 3 times. Our model shows 3 separate cakes. So 3/1 is equivalent to 3. 3 is not equal to 2/3. So because of that, we can eliminate 3/1. Another way that we can check to see if 4/6 is the correct answer is through multiplication. We can take the original fraction of 2/3, the amount that Amber ate of the cake that she sliced, and multiply it by the factor of 2/2. We can multiply our numerators, which will be 2 times 2, which is equal to 4, and multiply our denominators of 3 and 2, which will equal 6. The fraction will equal 4/6.